Okay, so this is solve trig equations in radians part 2. So I'm going to skip that introduction and get straight to the question here. For the introduction, you can refer to part 1. So here we're going to solve this trig equation. We've got 2 times the square of cosecant x plus 5 times cosecant x minus 12 is equal to 0. And I'm looking for every valid solution in between 0 and 2 pi. All of this obviously is done in radians. Looks like a bit of a mess. I'm going to clean it up. I'll clean it up with this substitution. Let's say that a is equal to the cosecant of x. If a takes the place of the cosecant of x, then this equation becomes 2a squared plus 5a minus 12 is equal to 0. Now, this just so happens to be factorable, but let's say you didn't see that. We can go straight to our solution using the quadratic equation. A is going to be negative 5 plus or minus the square root of 5 squared minus 4 times 2 times minus 12. So it'd be plus 4 times 2 times 12. All over 2 times 2. Okay, there's a video on the quadratic formula if that went too quick and you want to review how that works. So a is negative 5 plus or minus 25 plus 8 times 12, which is 121. Square root of 121, which is 11. So it's negative 5 plus or minus 11 all over 4. So a is equal to minus 5 plus 11, which is 6 over 4, or a is equal to minus 5 minus 11, which is negative 16 over 4. Now, 6 over 4 is 3 over 2. So my two solutions are a equals 3 over 2 or a equals negative 4. But I wasn't looking for a. I was looking for x, and the cosecant of x is equal to a. So that actually gives me these solutions. I substituted a in just to make my math look easier, and now I'm going to sub it back to deal with the original question. So the cosecant of x is 3 over 2, or the cosecant of x is negative 4. Now, if the cosecant of x is 3 over 2, then that means the sine of x is 2 over 3. Because remember, the sine of x is 1 divided by the cosecant. Or if the cosecant of x is negative 4, that means that the sine of x is negative 1 over 4. Why am I converting it from cosecant to sine? Because the calculator I bought will deal with sine, won't deal with cosecant. So we make sure our calculator's in radians. And if the sine of x is 2 over 3, I'll take 2 over 3, and I'll find the arcsine, that's sine to the negative 1. X is, so my first x value, x1, is 0.7297. If the sine of x is, well, let me deal with the other answer here. So one possible solution is that x is 0.7297. That's in radians. And if I was to multiply that by 180 and divide by 3.14159, it gives me 41. So that's about 41 degrees. Now, we're going to do all the work in radians, but knowing it in degrees will just help you draw a clearer picture. So this is x1 here. x1 is 0.7297 radians. Another angle that has exactly the same sign as this is going to be over here. It's going to have the same opposite over hypotenuse. This angle here, I'm going to call it x2. And the reference angle down here is going to be the same as that one. That's x1. So that means that x2 is equal to 180 degrees minus x1. So x2 is pi radians, because pi radians is 180 degrees, minus x1. So x2 is pi minus 0.7297. So it is 2.41. So x1 is 0.7297, x2 is 2.41. Both of those angles in radians will satisfy this equation here. But notice I didn't yet deal with this. The sine of x could be -1/4. So if the sine of x is -1/4, then that could make x also near -1/4. x3, the third valid solution, is -0.2527. Now, that shouldn't surprise you too much. Remember, for small angles, sine theta is equal to theta. That's the small angle approximation, which of course only works in radians. So if we're dealing in radians, and the sine is -1/4, the sine is -1/4, the angle is nearly -1/4. It's off by a little bit. So that brings us -1/4 is here. That's x3, this angle in here. However, remember, we're looking for all values of x between 0 and 2 pi. So the calculator is giving us a valid answer, but it's none of the answers we're looking for. We're looking for positive answers, not negative answers. However, we do have a positive answer. If we go all the way around here, this angle is going to have the same sign as that angle. Call that x4. And x4 is a full rotation, 2 pi, minus 0.2527 radians. x3 is 0.2527 radians down here. x4 gives us the same terminal arm, ends in the same spot, but this angle goes all the way around and then just minus that. So x4 is 2 pi minus 0.2527. So it's 6.03 radians. Now, am I done because I have 4 solutions? The answer is no. I'm looking for 4 solutions between 0 and 2 pi. I know ahead of time I'm looking for 4 solutions because this is a quadratic, and a quadratic has 2 solutions. And then on the interval from 0 to 2 pi, because that's a full cycle, each of our trig functions is going to have 2 solutions, or can have 2 solutions. The other solution I'm looking for is going to be down here. You see, sine is positive up here and up here. So if the sine is positive, I'm looking for 2 angles up here. If the sine is negative, I'm looking for 2 angles down here, because y over r is going to be a negative for both of those. Let me draw it out. So I've already got a solution here, where this angle down here, we've called that x3. My other valid solution is going to be over here, where that's the magnitude of x3. Now I know x3 is a negative. I'm just writing in magnitude. Make it positive. But I'm looking for this angle here. Clearly this angle, call it x5, is going to be pi plus x3's magnitude. So my 5th angle that I found is going to be pi. It's a 180 rotation plus that angle down there, because that angle is going to have the same opposite hypotenuse fraction as this one. So that's going to be pi plus x3's magnitude, so plus 0.2527. Now, if you dig around in your math textbook, you can find a chart that says if it's sine and it's positive, or if it's cosine, you add pi, you subtract it from pi. I prefer your goal is to understand it. So I would rather that you draw this out, you label the angle that you have, let's say that's x3. Then you realize that that's the other angle with the same sign is going to be the other angle where in here between the x-axis and your terminal arm, you've got the magnitude of x3. And then from looking at your clear picture, you figure it out. That's pi. And then we're adding that, so that's pi plus the magnitude of x3 in this example. Okay, so my x5 angle is going to be 2 pi plus 0.2527. So that gives me 6.536. Now remember, I was looking for every solution between 0 and 2 pi. x3 is not between 0 and 2 pi, so I'm not going to include it. So my solutions are x1, x2, x4, and x5. So I've determined that if I'm solving 2 times the cosecant squared of x plus 5 cosecant x minus 12 equals 0, x is equal to 0.7297 or 2.41 or 6.03 or 6.536. All of these angles are in radians. These are 4 valid solutions to this equation here in between 0 and 2 pi. You can verify that by taking any of these angles in radians, plugging them into this equation, and seeing that the left side turns into 0.